In this video, we are going to see about insertion sort. Insertion sort. This algorithm is also a simple sort algorithm. This algorithm works by taking elements from the list one by one and inserting them in their current position into a new sorted list. If the element next to the current position is smaller, then they are inserted to the current index location and value in the current index position is shifted right. Finally, this algorithm builds the final sorted array at the end. This uses n-1 iteration to sort the array. Example of insertion sort. Let's see the book example itself. Here, in this algorithm also, while sorting, we split the array into two parts, sorted array and unsorted array. To differentiate, sorted one is shaded in blue and unsorted one in white. Initially, the first element, index 0 position value, that is 44, is taken and it is considered as sorted one and put in sorted list. Now this 44 is compared to the element next to it, which is 16. As 16 is less than 44, they are swapped. So 16 and 44 are considered as sorted list. Next, 44 is compared to the element right to it, which is 83. As 83 is greater than 44, we need not do anything. Now 16, 44 and 83 is considered as sorted. Now 83 is compared to its next element, that is towards its right, which is 7. As 7 is the smallest of all the elements to its left, the values are shifted one after the other and 7 is inserted at index 0. Here we have to note that before shifting we move 7 to a buffer. Buffer is nothing but it is a temporary storage location. Once all the elements are shifted towards right one by one, then 7 is inserted to index 0. Now our sorted list have become bigger. 7, 16, 44 and 83 are considered as sorted. Now 83 is compared with 67. As 67 is less than 83, they are interchanged. Here also buffer is used. Each time when we swap, buffer is used. Now 7, 16, 44, 67 and 83 are in sorted list. 21, 34, 45 and 10 are in unsorted list. Now again the 83 is compared to element in its right, which is 21. As 21 is less than 83 and also it is less than 67 and 44, the values are shifted right and 21 will be inserted at index 2 position. Here also don't forget about the buffer. Now in sorted list we have 7, 16, 21, 44, 67 and 83. Now leftmost element in sort list is 83 and the rightmost element in unsorted list is 34. So 83 is compared with 34 as 34 is less than 83, 67 and 44. These three values are shifted towards right and is inserted at index 3 position. Next, 83 is compared with 45 as 45 is less than 83 and also to 67. These two values are shifted towards right and 45 is inserted at index 5. Now in unsorted list, we have only one element and that too is 10. Now this 10 is less than 83, 67, 45, 44, 34, 21 and 16. So all these elements are shifted right side and 10 is inserted at index 1. Now all the elements have been sorted and our final sort list is created. As in this algorithm we are inserting the smallest element to its correct index position, this algorithm is called as insertion sort algorithm. just because we are inserting the element to its location. Next we see the pseudocode for insertion sort. The pseudocode for insertion sort is a 6-step process. Let's see step by step. Step 1. If it is the first element, it is already sorted. This is because we consider our first element as sorted and we say this as it is already sorted. Step 2. Pick next element, that is, the element towards its right is selected. Compare with all elements in the sorted sublist. Step 4. Shift all the elements in the sorted sublist that is greater than the value to be sorted. So, all the greater values are shifted rightwards and the value that is to be inserted are inserted in that position. Step 5. Insert the value. Step 6. Repeat until list is sorted. So, these 5 steps are repeated until all the elements get in sorted order. Next, we see the advantage of insertion sort. Here in insertion sort, the performance and efficiency of the algorithm is much better than bubble and selection sort. Next, we see the animation video of insertion sort. This is how actual sorting is done with the help of a buffer. At first, 44 is selected and it is considered as sorted. Next, 44 is compared with 16. As it is less than 44, 16 is moved to the buffer and 44 is shifted right. Once 44 is shifted, 16 is inserted in index 0. Next, 44 is compared with 83. As 44 is less than 83, no change is made, but 83 is added in sorted list. Now, 83 is checked with 7. As 7 is less than 83, 7 is moved to buffer and 83, 44 and 16 are shifted right one by one as you see in the video. Once shifted, 7 is inserted at index 0, which is inserted at correct place in sorted list. Now, again we check 83 with 67 as 67 is less than 83. 67 is kept in the buffer and the element 83 is shifted right and 67 is inserted in index 3 in sorted list. Next, 83 is compared with 21. As 21 is less than 83, all the elements in sorted list, that is greater than 21, are shifted right. And 21 is inserted at index 2 position. Now 83 and 34 is compared. 34 is less than 83. So the values are shifted till 34 can be placed in its correct position. Now 83 and 45 are checked. 45 is less than 83. So values are swapped. Next, 83 and 10 is checked. As 10 is less than 83, 10 is placed in buffer and all the elements except 7 is shifted towards right. And then 10 is placed in the index 1. So this is how the insertion sort works.